All right, so recording started. Good morning again, everyone. So we're going to start a new module today. So you've noticed probably that the modules are a lot shorter, right? Especially compared to module 2. Module 2 was the one that was like 2 weeks long or something like that. So the idea here is that there's a lot of stuff that we covered in module 1, 2, and 3, okay? Especially regarding writing code from scratch and stuff like that, but also a little bit of syntax. So what I want you to keep in mind as we go through module 4, 5, 6, etc., is that we are going over a chapter of the textbook that assumes that you never heard about programming before. So if you need that kind of, this is going to provide it to you right in time, right now in the semester. But all of that stuff should be relatively easy to absorb because we covered most of it already. And then we focus more specifically during those module 4, 5, 6, etc. We focus more specifically on the little details, right? The technical details, like we knew about 3 data type. Okay, now let's look at all the data types that are available in Java. Okay, so that's really the philosophy right now for this part of the course. All right, so let's get started with some announcement. I think I have only one announcement, yes. So the announcement is spring break is here. So next week is spring break. So normally during spring break, there is no teaching related activity. So that means there's going to definitely be no lecture during next week. So Monday and Wednesday next week, no lecture, be it on campus or online, no lecture at all. There's going to be also no assignment due during the spring break week. It's kind of like a protected week, okay? But what we're going to do for the spring break is I'm going to hold the office hours, and I'm going to ask the TAs also to hold their office hours during spring break, okay? The idea is, I think we are at a good time in the course where if you are falling behind, well, this is kind of your last chance, right, to recover, because after spring break, it's going to be 1 week, a new module, 1 week, a new module, 1 week, a new module. And the pace is going to make it hard, to go back and catch up while you also move forward. But spring break is right at the right time, pretty much in the semester, meaning that if you feel uncomfortable about anything that we covered until now, that's your chance to dig back, okay? But don't waste that chance, very important, okay? This is, like I said, this is like the last time you're going to have a week this semester where you don't have new material coming at you, you don't have new assignment and stuff like that. So use it, okay? And we are going to have like all the office hours available. Use as many as you want, okay? We don't charge you for like if you use more than one office hour. So go ahead, go nuts. Use those resources that are available to help you catch up, and so that after spring break, I would love for everybody to be like on the same page. Okay, ready to move on and finish module 6, but we caught up if there was a need to catch up. Okay, so do that please for me. All right, so we still have the, I'm going to have to remove that, but the idea is that I want to remind you constantly that yes, you already know how to program, right? Module 1 to 3. But now we talked more about data types. The big theme in module 4 was data type conversion. Okay, that's actually something that's going to kind of follow you for the rest of your career. Every time you interact with a programming language, you need to know about that. Then we talked about conditional statement. We revisited the conditional statement, and there was a little bit of syntactical sugar there, right? So what I call syntactical sugar is, look, you can write some conditional statement as a switch, or you can use a ternary conditional operator, okay? These are not the most fundamental thing to remember, because you could do everything anyway with a base if statement, if else, like I taught you to do, in module 1, 2, and 3. But then the important part of that module is more the Boolean expression aspect, okay? So we took a look at the conditions that we write in an if statement, but whatever we said is true also for any condition that we write, like for example in a while loop, right? It's exactly the same thing. These are Boolean expression either way. So we took a closer look at Boolean expression in module 5, and that's probably what you need to really focus on understanding 100% when you work on that module. Okay, so there's going to be an IE for module 5 that's going to come after spring break. I didn't want to rush that this week. You have other things due this week already. So last session we completed module 5. So now we're going to jump in the next one, module 6. The other good news is module 6 is called Useful Methods. and it's actually, how to say, in terms of complexity, difficulty, okay, it's not difficult. It's more like, I'm going to explain that in a minute, but it's more like, let's take a tour together of a bunch of available methods in the JDK. Okay, since day one, we started introducing, system.out.println, and oh, look, this is how you use a scanner. This is how you use math.sqrt, square root. Okay, so we introduced here and there a bunch of methods that come from the JDK and that are there to make your life easier so that you don't have to write the code to do all those things, right? Well, there's a ton of those methods in any modern programming language, okay? Some people refer to that as a standard library of the language. So what we're going to do in module 6 is we are going to just take a tour of some of the most important methods that are available in the JDK that you can use. So it's relatively easier compared to, let's say, Boolean algebra or data typecasting. Okay, these are like hot topics that have concept behind them. Here, when we look at method and I tell you, well, okay, this is how you use this method, this is the name of the method, this is how you call it, what you give to it, what it returns to you. You see, this is more like a catalog type of information that I give you. So the big thing with this is that you are going to be exposed to a lot of stuff. Try to remember what exists, what's available, and don't try to remember all the details in one shot, because all the exams are open book for a good reason, which is at the exam, I want you to know, for example, that there is a method to compute the square root, and it's called math.square root, SQRT. But the details about this method, if you have to look them up, you can look them up. Okay, so you have to separate, all of the details from actually just knowing what's available, what it does, and how to use it. Okay, that's what we are going to focus on the lecture today. And then the details are important, but the more you use those methods, okay, the more you're going to get used to looking up the documentation on them and applying what you read there. And after you do that like five times, maybe 10 times, I don't know, then you're going to completely internalize that stuff. Okay, so it's going to happen naturally. All right. So let's talk a little bit about the module. I mean, nothing really new. I mean, all the modules are following the same structure, right? So we are going to have a reading assignment. Watch out, there is an appendix, but the appendix is the ASCII character set table. Okay, that's the table of all available characters in the ASCII chart. I don't need you to memorize the stuff. Again, it's a case of, I bookmarked it. I know where to find it in my textbook. I know how to use it. That's good enough. Okay. And chapter 4 will be the main reading assignment. So the PQs and GQs are already released. They are going to be to help you, like, make sure that you understand that part as usual. What else do we have? We have, as learning activities, we're going to have practice exercise, non-graded, practice quiz already mentioned, GQ graded quiz, and we are going to have some coding math exercise. So I already released the module 6, and the auto grader is already scanning to see if you completed any of the G06 exercise and giving you point for them. Okay, so don't worry if you wake up this morning, you go to your grade book and you see that you received a 0 for G06. It's just the auto grader that's going to, every day I'm going to run it, every few days I'm going to run it, and it's going to just update based on what exercise you completed there. Okay, so business as usual. Here are the practice exercises that I recommend for this module. As usual, if you need more practice, right, you should be able to tackle almost every exercise in the textbook for that chapter. Okay, the ones that have 1 star are a little harder. The ones that have 2 stars next to their number are a lot harder. So your mileage might vary. Okay, some of them might be a lot harder to complete, but globally speaking, you have the knowledge, the base knowledge, to work on any of those. Okay, which was not true in module 1 to 3 because we only exposed to a subset of Java. Now we are looking at all the gory details of the language. Okay, these are the graded exercise on coding math. So the links are here. The links are also in the module on Canvas. Okay, and that's it for the logistic for that course. So let's get started. So we are going to take a tour of the JDK. Well, not the whole JDK, but some part of the JDK. We're going to talk, for example, about the math methods. So we already introduced some of them. I just want to do a revisit, okay, and introduce a few more that we didn't talk about until now. So one thing that we didn't talk about at all were the mathematical constants that are available. Move that guy out of the way here. So the way that you access this mathematical concept, it's all inside a class called math. Okay, uppercase M, this is the name of a class. So math dot something allows you to access what's inside that class. Well, there are two constants that are commonly commonly used, e and pi. So math.e, math.pi, all uppercase are going to it's going to be the notation to allow you to reach those constants and use them. So for example, if I want to do a system.out.println and I want to display math.e, there we go. This is how I write it, and I'm going to do math.pi real quick as well. And you will notice that I don't need to do any import. I have an import Java util scanner here, but this is because this is my live coding file. So since I use a lot of scanner in the program example, then I want to not forget, to do that import. But I could, comment this out. It's going to work just the same way. So let me compile this. And then let's run it. There we go. I have my value for E, my value for pi, okay, at as many decimal that a double can allow me. So this should be something like 16 significant digit here, something like that, okay, if I remember correctly. So that's it, okay? That's how you access mathematical constants. There might be other, but I mean, there's no point in doing like the full listing, right? If you ever need to look at the full listing, you consult the Java documentation on the Oracle website. So you Google oracle.com and Java doc in one word, and you're going to get the official documentation, okay? I also put here a little a page that I found that has kind of like a summary of the most frequently used, math function, but we are not going to do scientific computing in this class, so we're not going to use a lot of those methods, okay? Trigonometric methods, there's everything that you could wish for, I guess, or everything that you could expect, right? Sinus, cosinus, tangent, arc sinus, arc cosinus, etc. They're all there, okay? The only thing really that I want to impress on you during this lecture is how to use them. Something that you use a constant. It's math with an uppercase M dot and then the name of the method you want to call, okay? So for example, if I want to do here math dot here, let me be lazy, and if we use this, instead of math dot pi, I won't say math dot sin 180 degree, okay? And this is the one thing I want to draw your attention to. If I try to do math dot sin sinus of 180 degree, there we go, it's going to give me a weird result, okay? But if instead I say math.sin of math. I'm not in the right window. There we go. All right, let me try to fix that. Dot pi, okay? Then, of course, it's going to make a little bit more sense, okay? So please note it's not exactly 0, right? It's exponent to the power minus 16, so it's 0.000000001. Okay. Anyway, so you know what this is, where this is coming from, right? Floating point imprecision. But the idea is that what I'm trying to underline here is that all of the trigonometric method available in Java, all of them are using arguments that are expressed in radians. Okay, so you have to know that before to get on board. If you try to use 360, 180, 90, and you think that you're going to get like those angles, they're not. This is not what you're going to get. So you have two methods that are going to take a double and return a double. The one that converts whatever you pass here to radians. So it's expected that you're going to pass degrees and get radians out of it. Or if you call math 2 degrees, you're going to pass a value that is expressed in radian, an angle expressed in radian, and you're going to get degrees out of it. Okay. So this is pretty much all you have to worry about, to really remember about those methods. And then, the names are like, the same names that you saw in K12 and stuff like that. So this is not difficult to find the exact trigonometric method that you need when you need it. Okay. So what else? So constant trigonometric method. What about exponential method? So there are like 4 of them: the log, natural base, the log base 10, the exponentiation, and the power. Power being the one that we already discussed before, d1 to the power d2, right? You write that math.pow d1, comma d2. And please notice that all of those methods, they are operating on double values, right? Double data type. So they expect to get doubles. You should expect them to return to you double results, okay? And then the only one that we really didn't introduce at all was e to the power, whatever exponent you want to specify here. So if I go in the code and I say, let's display the value of math.e, it's a constant e, and then I did something like whatever e to the power 1. So this is not Java syntax, it's just text, okay? And then I say math.exponent power 1, okay? I run this. My compiler is like having a case of a Monday morning or something here. It's a little bit slow. So this is exactly the same value, right? Because this is e to the power 1. Now, some of you might notice here that I put a 1. I didn't put a 1.0. So first thing I want to debunk is that if I put a 1.0, it's going to be exactly the same thing. Okay? Build. Run. There we go. So no doubt about this. 1 and 1.0 give me the same result. But I said that those methods expected double data types parameters. So what happens when I pass to a method that wants a double value as parameter? What happens when I pass something that is not a double? Implicit typecasting. Okay. If everything goes well, it's implicit typecasting. If for some reason I might lose some precision, some data, right, then it's going to be explicit typecasting. So I would write something like that. So I can always do explicit typecasting whenever Java does implicit typecasting. It's just kind of being redundant. Okay. Java already does it for me. But I can write the syntax that says to Java, I want to make sure you do it. And Java is like, yeah, sure, I'm already doing it. You don't have to yell at me and stuff like that. So here we have just the idea that everything that we learn about data type casting, we learned it in the context of expression, right? But that's going to apply also every time you call methods. And we're going to discuss more about that in, I think it's in 2 modules when we cover in depth, methods inside out. But the idea is that, yes, if I pass a value that is an int and the method expects a double, then it's going to try to upgrade my int value to a double data type value. Okay, and that's exactly what implicit typecasting is about. And sometimes, if I try to pass something that doesn't match what the method expects, well, sometimes I have to do explicit typecasting to make it work. Okay, so those topics that we covered mostly, like I said, in the context of expression, arithmetic expression, that knowledge comes in handy as well when you start calling methods. Okay, so what matters really when you call a method is you need to know what is the name of the method. You need to know how many parameters it's going to take, requires you to provide, what are the data type of each of the parameter, what are their meaning, and then whether or not the method returns something and what is the meaning of that thing it returns. If you know all of that about a method, that's it. You don't need to know the details of how it does its work. You can use it in your own code. So that's it for the exponential method. Here comes the category miscellaneous. So square root, absolute value, the max between 2 values x and y. So this one is going to return x if x is greater than y, or else is going to return y. And the mean, between 2 values, return that to me. So the data type that I wrote here and that I highlighted in red, this one is double. Okay, so this is kind of like what we've seen so far. But this data type here, t, t, and t, what does that mean? Well, I just meant, that the return value for each of those 3 methods can have a data type that is going to be one of int, long, float, or double. So you could replace t by any of those keywords, okay? And there is a version of the method math.abs that returns an int. There's a version that returns a long. There's a version that returns a float. There's a version that returns a double. So it's kind of like, for the first time, we are encountering methods from the JDK that have multiple versions of themselves. They have the same name, math.abs, but they return different value. So just to play a little bit with that and see what that entails, right? Let me clean up that mess here. There we go. So let's say that I have an int result. So I have a variable of data type int. This is where I want to store whatever the method I'm about to call is going to return to me. Okay. So I'm going to call something simple. I'm going to return. I'm going to call math.max. So if I do math.max between 2 and 3, well, it's going to return 3 to me. Okay, and then I can do a system.out.println result. Okay, let's compile this, run it. Okay, 3. All right, this is what we expect. So that means also that there is a version of the max method inside the math class that accepts what is the data type of that thing? Int. It's an integer literal. Integer literal in Java has the data type int by default. So this is an int. This is an int. And it returns something that I can also assign to an int value, an int variable, sorry. So there is a version of this method that works pretty much all on int. And then do I have like a version that works on float? I'm not going to do the 4 of them, right? But just to show you, result 2 equal math.max. And I'm going to say, for example, 2.1, 3.1, okay? And if I write it like this, what is the data type of those guys? You guys remember?
Double.
Yeah, double, bingo, okay? So doubled, and I expect a float, okay? So what I'm going to do first, I'm going to just put an F here, just to mean, I want these literals, these floating point literals, to be seen as float data type. So now I'm using the version of the method that is going to take 2 float parameters and return a float result. And I'm going to display just that one. I'm not going to display the first one anymore. There we go. Seems to be working. Okay. All right. Now the funny thing, the interesting thing is when I have int result like this, and then I do this kind of stuff. Now I'm mixing and matching, right? I'm calling a version of the max method. But what I tell you about max, by the way, is true for min, it's true for AVS, it's true for every method in the JDK that try to, to have several versions that work on different data type, okay? So here, what I'm saying is I want to call the version that works on a float, and I want to store the result in an int variable. Let me fix that part of the code as well and run the thing. And now the compiler is yelling at me. So incompatible types, that's when you see that in a compiler error message, that means you have data type casting gone wrong, something like that, okay? Possible lossy conversion, that's called, Java doesn't want to do implicit typecasting because it's afraid of losing precision from float to int. So what's happening here? So here, there are 2 ways to interpret that, okay? One way would be to say, I'm giving a float here, but since I expect an int, I should be giving an int and an int here. Or another way to interpret that is to say, I'm passing a float and a float to that method. There is a version of that method that accepts 2 floats as parameter, but that version returns also a float, okay? No matter what data type you give to max, this is the same data type that is going to return to you, okay? So if I give 2 floats, I'm expecting to get a float, and that float is going to be assigned to a variable result, and that variable result is not the proper data type. Now, if I put result as a float, much better, okay? Going to run it, trying to run it. Okay, now it's working, right? Similarly, let's keep playing a little bit with this example. What if I have a variable result of type double, okay? Well, it's going to work as well, but what's going to happen is that this method, it gets a float as argument here, a float as argument here. So I'm calling the version of the method that works on floats. It's going to return to me a float data type value. I try to assign a float into a double. that is implicit casting. Okay, the float is this big, the double is this big, no problem. I can upgrade the float to still have the same value, but be stored inside a double data type variable. Okay, so that's it. That's just the first time I'd made a big fuss out of it, because this is the first time we encounter those kind of methods that are like, they almost like have a variable geometry, right? That means that it's not just one method, it's an entire group of methods with the same name, and each of them is meant to work with different data types, okay? So that's kind of like the novelty for this slide. Next slide. So we're getting progressively into stuff that is going to be more and more, I would say, usable in this class, okay? Trigonometry, we're not going to do a lot of trigonometry. There are a few exercises in the textbook that play with trigonometry because it's assumed that all of you went through some trigonometry exposure, you know, during K-12, etc. So it's supposed to be non-territory. My experience is that a lot of people forget trigonometry faster than they learn it. I'm one of them. So when you get to college and somebody asks you about what you remember of trigonometry, it's kind of like hit and miss. Okay, so I'm not going to push those kind of exercise in the class, but if you like trigonometry, if you want some exercise like that, then there are definitely some in the textbook. The previous remark on the previous slide regarding the methods that work on different data types, definitely that's super useful, because we're going to encounter that by just using the JDK. And in COP2513, we are going to talk a lot more about that topic and write our own method that can actually work on different data types, okay? And then this slide here is very practical. You are going to have to round things eventually, okay? Converting from a floating point to integer, or even just converting from floating point to floating point, but you want to lose, you know, some of the decimals and stuff like that. So this is a page that's a slide that's really relevant for you. It's going to show you pretty much all of the 5 methods that are available in the JDK, in the math library, the math class, sorry, to allow you to do rounding of different values up and down. So far, the only way that we learned to round values was when we did something like, so hold on, let me get rid of this. So when we did something like, what was it? Equals, and we took a value like, for example, 42.1234567, okay? And then what we did with this is we took this, we multiplied it, remember, by 100, and then we converted the result to int, and then so all of that was converted to int to lose the decimals, and then we multiplied by 100.0. That's the example that we used when we were talking about data type casting, okay? So system.out.println, that thing, this is going to convert pretty much, this is going to truncate that value to, it's still going to be a floating point number, but it's going to be a floating point number where I have only 2 relevant, so significant digits after the decimal. And I did something stupid here. What did I do that's stupid? I multiply by 100, so this is going to be a double. I convert that into an int, I multiply by 100. Oh yeah, my end result is going to be a floating point number. So I got that wrong. I should put double here. Let's save that. Let's run it and see what it displays. All right, there we go. Okay, so in that case, there's a little bit of rounding snafu that I did there. Let me see. Yeah. I'm completely off my game here. We divided. We didn't multiply by 100. Okay. I would say this is a result of getting old, and it's not good, but it still beats the alternative. So I would recommend getting old. It's still better than the alternative. All right. So there we go. So we have truncated here everything that was past, you know, the second decimal digit. Okay. So there are better ways to do that. That was okay because that kind of showed how the truncation works when you do data type casting. So that was okay for the topic that we're talking at the time, but we have different methods here that are going to allow us to do this kind of stuff and actually much more. So let's take a closer look at what the methods are and what they can do for us, okay? So I'm going to kind of illustrate them real quick. And for the sake of time, I'm going to cheat a little bit, and I have code already ready here. So I'm going to grab this and paste it with the live coding example. There we go. Try to paste it. There we go. So what I'm doing here is I'm doing a system.out.println, right? It starts here and here. And inside the argument that I pass to my println is going to be me constructing a long string. So the long string is going to say, hey, I'm playing with math.floor, put a tabulation, remember tabulation, like horizontal spacing. And then after that, I'm going to put the value returned by math.floor called on 3.0. Okay, and then after that, the value returned by math.floor called on 3.1. And then after that, the value returned by math.floor on 3.9. And I chose those three values because they are going to make a difference later. Okay, not necessarily for floor, but for over method. So if I try to run that, there we go. It tells me everything is rounded down to 3.0. So math.floor doesn't convert a floating point number to an integer. Okay, we are still dealing with a floating point number, but it rounds it going down to the nearest integer going down pretty much. Okay, so it doesn't matter if you are this close to 4.0 like 3.9, you're still rounded down to 3.0. Okay, so we are going to compare that now to the other methods from the slide. So I'm going to put some code here that do a math.sailing. Question in the chat, what does the \t do again? It just puts space between the string. Yeah, it. So I'm not going to do the whole thing, but if you are curious, hang around at the end of the lecture, and I'll fill in some details. Okay, but pretty much the deal of the \t is that it puts this spacing. Okay, except that the spacing is not always the same. It's not like if I put a \t, I get 2 spaces. Or I get 3 spaces, etc. The number of spaces that I get depends because it's trying to align pretty much things in columns. Okay, so I'm kind of giving you the quick recap on that. But at the end of the session, please hang around just 5 minutes if you want. I'll give you the full story, okay, with full details. So it's just aesthetic. It's just to present things nicely in columns, okay. And this time we are going to call the sail. I think that's how it's pronounced. The sail method comes from ceiling, okay? And that one is going to do the opposite of floor, okay? Floor, ceiling, and I messed up my, yes, I was typing stuff that I didn't need to type here. This is my cut and paste that went wild. All right, let's try again. Let's clean it up. It's going to do the opposite of floor, okay? Floor is always rounding down. Ceiling is always rounding up. Would make sense. Floor at the bottom, ceiling at the top. Okay. The only thing that you have to pay attention to is that, yes, if you are at 3.1, 3.9, you end up at 4.0. If you are at 3.04, you end up at 3.0. Okay. So if I was putting something like 3.00001 here, then yes, the ceiling would be, a little bit different. Okay. But if it's exactly 3.0, which you know how hard it is to be exactly at the number with floating point number, then this is what we get. Okay, so that's 2 of them, floor and ceiling. Both of them, they take a floating point value, give you back a floating point value, but round it to the nearest integer, either going up or going down. And then the next one. So the next one is a little bit more interesting from a practical point of view, I would say. So if you know that you want to always round up and down, there you go. You have your method. This one, rint, okay, is going to round up to the nearest integer. So it doesn't go always up, doesn't go always down. It's just figure out, what you are the closest to, and then rounds up to that. So for example, 3.0 is closer to 3 than 4, so that's it. We get 3.0. 3.1, same thing. 3.9 is closer to 4.0 than 3.0. There you go. It rounds up to 4.0. Okay. So, but then again, floating point to floating point. And then we have 2 methods left. Actually, 2 methods left. I think we have only 1 method left. Let me double check this slide. We have 2 versions. That's it. We have 2 versions of 1 method. The name of the method is math.round. That one is going to take a double as argument, right? A floating point number, and then it's going to return to you an integer. So this one changes the data type of what it's trying to round up or down, okay? So we're going to take a quick look at how it operates. There we go. Here we are. So I'm just going to grab, like, again, my like cut and paste of the code, if I can grab it. Yeah. That's a little bit of time typing here and a lot of typos probably. So I'm doing the same thing, right? I'm calling math.round, and I'm calling here the version that works on double. Here I'm calling the version that works on a floating point number, and I'm going to display what they return each time. So let's go for it, run it. So yeah, this time it returns integers, and you see that the column alignment is messed up. So again, we're going to talk a little bit more about that when I introduce printf, okay? But for now, yeah, tabulation are usually good. They're not perfect, so we have another way to align in a nifty way, you know, things in column. I'm going to talk about that a little bit later. But the important thing here is that we get integer values, no more floating points, okay? And they have been converted to 3, 3, and 4, 3, 3, and 4 in both cases. So we are converting to the nearest integer, just like rint, okay? So the difference between rint and round is that they pretty much both convert to the nearest integer, but rint still returns that nearest integer value as a floating point number, whereas round is going to return it as an integer data type. Okay, so these are a little bit more commonly used than, you know, trigonometry and stuff like that in a general purpose programming class. So it's good to know how they work. And then we're going to finish the review of those numerical methods from the JDK with the random method. So I already introduced it to you several times, but every time I introduced it to you, I just, you know, gave you like the recipe to follow blindly, okay? And the recipe looked like something like that. You want a number, an integer, a random number between 0 and 9 included, then you write it like this. Now, if you want it to be between 50 and, let's say, 99, then you write it like this, okay? I always told you pretty much a formula to apply for a given exercise. This is a general formula. You call math.random. The thing that you have to know about math.random is that math.random returns to you a double value, and that double value is between 0 and, so 0 included, and 1 not included, okay? So we are in the interval 0, 1, with 1 unreachable. So I can get a random number that's going to be 0.9999999, okay? I'm not going to go up to 1. Okay, when you have this, why did we do this, by the way? Why did the Java implementer do this? Because now that you have a possibility to get a random number between 0 and 1 as a floating point, you can scale it up however you want. If you don't want between 0 and 1, but being between 23 and 24, right, you just add 23 at the top. So 23 plus math.random is going to give you a random number between 23 included and 24 excluded, and it's going to be a floating point number, okay? And then if you multiply that 0, 1 interval by b, then you're scaling up, okay? So if I don't want to just have like, you know, values between 0 and 1, but I want them to be between 0 and 50, not included, I multiply by 50 this term here, and that's it, okay? So between the shifting and the scaling, you can, with that formula, obtain any interval that you want. Okay, so there's not much more to say about random. I try to think about what could possibly, you know, kind of mislead you, lead you to make mistakes. The only thing that I could think about, and it's theoretical because I haven't seen yet a student fall for that trap, so it's probably me just being overcautious. Okay, but just for the sake of being complete in my introduction of the random method, let's consider this example here. Like, for example, if I say I want a random integer, so int value, okay, and I'm going to say value equal, and I'm doing 1 plus math.random, okay, so this is, typo notwithstanding, this is going to be a number between 0.0 and 1.0 excluded. I add a 1 to it, so now I'm between 1 included and 2.0 excluded. Okay. How do you do a D20? Okay, I'm going to address that because this is a very good question. I like that question. Okay, so, and then I multiply by 10. Okay, so what I would like to do now with this, I would like to obtain a random number between 1 and 10 as an integer. Okay, if I try to do something like this, let's go ahead and system.out.println that thing. Okay, so value, there we go. If I try to do something like this, I'm going to run it a few times so we see different random. Well, actually, I'm not going to run it because that one is a version that doesn't even compile. So it's telling me incompatible type. So we're getting that error a lot. Okay, well, yes, because we are learning about the type. So I'm making sure that we encounter that error as many times as possible so that you get kind of immunized to it, right? So incompatible type, possibly lossy conversion from double to int. So somewhere I get a double result and I want to convert it to int. Well, yeah, I get a double here, right? And I add an int to it, so the result is going to be a double. I multiply by an int, so a double multiplied by an int is going to give me a double, and I try to assign that to an int variable. So that's not going to work out very well, okay? So second possibility is you try this, you don't remember exactly the formula, right? You try this, and then you say, okay, possible lossy conversion, I need to do explicit casting. So I'm going to do explicit casting of whatever is a double in this thing, which is math.random, okay? And then we run that. And that works, right? It gives me a random number that is 1. 1 is between 1 and 10. So I run it again. Oh, what are the odds? Yep. And now this is where you want to spin that little inception top, to make sure that you're not in a dream world, because every time I call random, I get 1. So what's happening here? Actually, I should ask you what's happening, and then I will go to your question about the D20 in a second, okay? But why am I getting always 1?
It's taking 0 point a number and then making
Mhm.
it an integer and multiplying
Yeah.
it by 10.
So I'm converting my double, right? My double is between 0 and 1 not included. And if you convert actually something between 0 and 1 not included into an int, what do you get? You get 0. That's it, right? You drop all of the decimal. So this here, this part of the expression is going to always give me 0. And then I'm going to add 1 to 0, that gives me 1. And then I'm going to multiply by 10, that's going to give me 1. Okay? So that's it. I'm going to multiply 0 by 10. That's bad. I'm going to multiply 0 by 10. Okay, that's going to give me 0. And then I'm going to add 1 on top of it. So it's going to always give me 1. Okay, so that's a problem. How do I solve this problem? Relatively easy. I just need to do my type conversion here at the right location. So converting that math.random result doesn't do the trick, okay, for the reason that we just covered. But if I try to actually manipulate floating point values like this, and then at the end convert to actually an integer, well, it's going to give me a different result, that's for sure. So let's run it. So here I get, for example, 0.5. 0.5 times 10 gives me 5. 5, actually, for this example, I got 0.4 here, sorry. 0.4 times 10 gives me 4. Add 1 to that, that gives me 5. Convert to an int, that gives me the int value 5. So I definitely didn't get exactly 0.4 here. I probably got 0.4, 1, 2, 3, 4, 5, 6, as many significant digits as the double data type could store for me. But that's pretty much what happened here. I worked on floating point number for the whole expression, and then I converted the end result into it. And yes, that makes a difference. If I keep running this guy, there we go, I'm getting random numbers that are indeed between 1 and 10. Okay? All right, that's about the worst case scenario I can think of regarding random. So yeah, there's a hand raise. So let's go for the hand raise question, and then I will show you the D20.
Um, would it matter if you put the integer on the math.random instead of outside? Would it be the same thing?
Yeah. No. Like you mean like this? Let me make sure that I understand what you mean. If you put it right here.
Yeah, and then put math.random in parentheses. Would that be the same thing?
Yeah. Like if I put math.random in parentheses, this is by default what happened before because of the priority of operator.
Oh,
So the type conversion, the parentheses that we use to do type conversion, this is actually a good question. The parentheses that we use, to do typecasting, like around the name of the data type here, this is actually an operator. And even though it looks like just like a pair of parentheses, Java consider it as a special operator called the casting operator, right? So that casting operator has also a priority level, a precedence level, and its precedence level is pretty high. So it's applied here to math.random before we consider, the multiplication or the addition. Does that make sense?
oh yeah. Thank you.
Cool. So, and then let's finish up with the D20. So there we go. I'm going to use the same formula, right? So same thing here. I want to say, so I get 0 to 1 here. I'm going to multiply by 20. So now I'm getting 0 to 19, okay? If I round up to an int, 0 to 20, but 20 not included. So that means 0.0 to 19.9999999. I'm going to add 1. So now I'm getting from 1, the dreaded 1, to 20.9999999. And I want that to be converted to an int. So I cast it into an int, and now I get between 1 and 20 as an int. Okay, and we're going to run that a few times. Get me some balls we can roll. Okay, there's equals to 10, and I was too eager here. Run it again, a 5, a 9, a 6, 14, etc. So on and so forth. Okay. So it's the same formula, okay? Applies the formula, like blindly. So first level of understanding applies the formula blindly, okay? You just have to plug in the number here for shifting and the number here for scaling, okay? Second level of understanding, you understand what the formula does actually, and you understand why we have this int here, etc. And third level of understanding, you understand that if the int was put elsewhere, then that would cause, a different result. So this is what you do when you debug, right? You write a piece of code, and I would say it doesn't matter if you get it right the first time. If you put that int conversion in the wrong spot, it's okay, as long as you are equipped, you have understood enough from the lecture and the reading, you are equipped intellectually to say, okay, this looks like, there's a problem with the conversion. So now I have to retell myself the story. What happens exactly when I convert math.random? I get a 0. Oh, that's it. That's a problem. Okay. But that's what you're going to do constantly when you're debugging, right? You go back to what you've learned, try to apply to figure out why it's not behaving the way that you thought. Question in the chat. Instead of adding 1, can you just add 1 to the number you multiply by? It's different. Okay. I call that number the shift value. I don't want to make a big deal out of it, but it tells you pretty much where you're going to start. Okay. So if you say 1 plus math.random times something, that 1 is going to say the first random integer I'm going to get, and I focus on getting random integers because it's what we do most of the time, okay? But the first random integer I'm going to get is going to be 1. If I put a 10 here or a 5 or whatever, or 23, then my range is going to start at 23 included. Now, the second number here, the scaling, it doesn't tell me where the range ends. It tells me how many possible different value I want. Okay, so that's why, like, if you go back, listen, if you go back to the slide, all right, here we go, there we go. Like the formula A plus math.random times B, this one doesn't show the typecasting, okay, but it tells you it's going to return a random number between A, so this is where my range starts, and A plus B, excluding A plus B. Does that make more sense now? So each of the number has a different role. See what I mean? Yeah, okay. All right. And that's it. I went probably a little overboard on random because, like I said, generally people don't have problem with that, but I prefer to do that during lecture so that you guys are exposed to everything that can go wrong rather than, figuring out by yourself in the middle of an exam. So hopefully, you guys are not going to fall for that kind of trap. Okay, next topic. We are going to talk about the char primitive data type. So we already pretty much introduced, I would say, everything about the data char. that data type, sorry. I told you, it's a single character. I told you the way you write a single character literal in Java is using the single quote. So easy to remember, right? Single character, use a single quote. Double quote is for string, like entire text, okay? And it's not true of every programming language. Python, JavaScript do things differently, okay? So it depends on which programming language you're using. But here, for example, I declare a variable letter of data type char, so one character inside of it, and I assign to it, I initialize it with the literal, the char literal, single quote, uppercase A, single quote that correspond to the character uppercase A. And I told you already that this character uppercase A inside the memory of the computer, inside the variable letter, it's encoded as a number. And that number is an index in what we call the ASCII table, okay? Which stands for American Standard Code for Information Interchange, maybe? I can forget it every year, okay? But anyway, this is actually a table that agrees that when we talk about number 65, okay, that represents the uppercase A. So we've seen that table already in the lecture, okay? What I already mentioned previously is that inside the variable here in the memory of the computer, everything is coded in binary. So really, the value 65 is going to be encoded like this. And just for the sake of going back to stuff we talked about, if I wanted to read that value in hexadecimal, then I could convert it like that. Okay. So make sure that you're comfortable with those basic conversion. Okay. It's not that difficult. Learn the recipe or bookmark it and go back to it. Make sure that you can do those conversions. Now, one thing that is new, we talked a little bit about Unicode, but mostly I use ASCII because ASCII is smaller, kind of easier to understand, okay? But ASCII doesn't have all the possible characters from every possible country in the world. It only focuses on really the basic alphabet, A, B, A to Z, uppercase, lowercase, and a few symbols. So the ASCII table is what we had at the beginning, but it's not good for, for translating text in different language and stuff like that. So what came next is a Unicode table. And the Unicode table is just a bigger version of the ASCII table. And the people who designed the Unicode table were smart enough to say, you know what, since the Unicode table is this much bigger than the ASCII table, we are going to make sure that the entire ASCII table fits at the beginning of our Unicode table. So if you say, for example, I want to represent the uppercase A character in Unicode, you can do that. You can do that with a literal in Java. You're going to use a single quote, single character always. But now, inside those single quotes, you're not just going to put the letter A, you're going to put \U for Unicode, and then you're going to put 4 hexadecimal digits. So here's an application. If you needed one, for hexadecimal, when you write codes in Unicode, you generally write them in hexadecimal, not binary or anything like that, okay? Because it's more compact. So here, for example, 00441, well, 41 is a hexadecimal for 65. So the ASCII code of the letter uppercase A that was stored as the decimal value 65 in letter is now stored as the decimal value 65 still, but inside letter, and it's using 16 bits to actually store it. How do I know it's 16 bits? Because each hexadecimal digit takes 4 bits, 4 binary digits to be coded in memory. So this corresponds to 4, 8, and then 16 bits. Okay, so it's just another code, and we didn't really talk about this one. Okay, but for all intent and purpose, it overlaps with the ASCII table. So everything that you understood about the ASCII table, you pretty much already understood it about the Unicode table. Okay, like if I tell you, for example, in the ASCII table, the range for character A to character Z uppercase is code 65 to 90. Well, what you get here is code 65 written in hexadecimal and code 90 written in hexadecimal, and corresponding code in the Unicode table. But of course, the Unicode table is much larger. And what does it have? Well, it has a Mandarin character, it has Russian alphabet character, it has all sorts of character, Greek letters, etc., that are not just based on the part of the base Latin alphabet. okay? And that allows us to render text in different languages much more conveniently, okay? So I cannot show you an example of rendering that kind of text in the console. Console is a little limited for that, or at least the console we're using. But if we were like to open a pane, a graphical user interface pane, with Java, then we could actually display, for example, Greek letters here just by referencing to their Unicode value. And then the graphic user interface will render these exactly how they are meant to look. So alpha, beta, gamma, for example, in this example. So that's pretty much it. Okay, there's 65 something thousand possible characters. That's enough to cover pretty much all the alphabet that we're using on this planet. Even the special character are taken into consideration. So remember that \t that we just talked about, actually, that \n, that means, go to the next line. Well, these are still characters. So they are in the ASCII table. So you have an ASCII code for them, and you have also a Unicode for them. So when you want to say in the middle of your text, I want to go to the next line, you can \n in your string, or you can give me the ASCII code, or you can give me the Unicode for it. The last thing I'm going to say about this, because that's pretty much all there is to say here about Unicode, right? We're not going to use it too much. But the last thing I want to cover is you have two ASCII tables in the appendix of your textbook. And the first time I looked at the ASCII table, I was like, well, this is not the most, okay, how would I say, the most natural way to introduce an ASCII table. Okay, if you go back 2 lectures ago, I think it was, we have an ASCII table in the slide. I use an ASCII table that is, listing all the decimal numbers, and for each of them, what is the character that has that code, okay? Well, in the textbook, the ASCII table that you have in the appendix, they do things a little different. So they are kind of like 2-dimensional like that too, but the way that you use them is really different. So let's say, for example, you want to find a character, like the character uppercase A. So you locate it here in the middle of the table. And now you want to know what is the decimal ASCII code for that character. You're just going to look up the row on which it appears, row number 6, and then the column. And that tells you the character uppercase A as decimal code 65 in the ASCII table. And there is another table in the appendix as well that does pretty much the same thing, but it does it using hexadecimal notation. So let's have at it again. Okay, we want to know the code of, for example, the uppercase letter A again. So we locate it in the table. Then you take the number of the row, you take the number of the column, and this tells you that the character uppercase A in Unicode, in ASCII, sorry, is encoded as 41, the value 41 hexadecimal. So if you want the hexadecimal code, you look at this table. If you want the decimal code, you look at the previous table. Okay, just a little tweak, take on how to use and present this table, but nothing really fundamental there. One thing that we also talked about briefly when we introduced the char data type was the fact that the char data type is, pretty much a number, right? I even just went back over that fact 2 slides ago. So what I'm going to add to that is that now that we talked about data type casting, I can tell you a little bit more of the story. And when you write something like, for example, let's start with this one. When you write char C equals, but you don't want to use, the single quote notation. You don't want to specify a character literal. What you want to specify is a code, an ASCII table code for that character. So you write char C equal 97. This is accepted by the compiler. And it's, again, a case of implicit type casting. The compiler realizes that you are providing an int value here. It realizes that you're trying to shove that int value into a char. So it makes a special case because it says, well, an int, is not a char, but I know what you mean. You're trying to give me the code for the ASCII table. So writing this here is just like if you wrote this explicitly. So you don't have to do the explicit typecasting, okay? But Java does it for you implicitly. It converts that 97 to the data type char. So now it represents the character And I have no idea what character 97 is. I hope it's displayed below. Yeah, it's displayed below. So it's going to display that character, okay, and convert. Sorry, it's going to take that value 97, convert it to the data type character, so that now whenever you display the variable c, it's going to display the character. And you can do it weird like this. You can say, for example, I have a variable I of data type int, and now I'm assigning a character literal to it. So what does that mean? Again, Java should refuse that, should say, a character is not an int. But again, Java says, okay, maybe you're trying to be smart with the index value. So I'm going to auto-convert for you that character A, which is decimal code 65. I'm going to convert it to an int. So now I have the value 65, and I'm going to store that in an int variable. So Java is super flexible when it comes to character. It goes from character representation to the index that represent a character in the ASCII table, back and forth between the two without any problem. Okay. Question in the chat. To check Unicode characters, can you do something like if letter greater than blah blah to check if a letter is higher than some other? Yes, absolutely. You totally anticipated I think it's the next slide or something like that. So yes, very good question. You can definitely do that, and that's the whole reason for which we talk about the integer / character equivalence in Java, because now that you know that one, that the characters are stored as integers in the variable, which I told you already a few lectures ago. But now you know that Java is super flexible and does implicit typecasting back and forth between integer and character. The next step is exactly what you were thinking about. The next step is, can I do arithmetics on characters? I can do arithmetics on integer value, right? So what holds me, what prevents me from doing arithmetics on character? Well, nothing. It's one of those, I wouldn't call it an advanced programming trick, okay? But it's one of those things that when you get into the mindset of a programmer, you start looking at things with their data type and you start thinking about things like that. I want to do arithmetic on characters, okay? So that's just what comes with one of the perks that comes with the job, I guess. So let's do exactly that, okay? Let's do some arithmetic on character. I'm going to do some basic addition, subtraction here, and then next slide, we are going to look at the comparison that you were thinking about in detail, okay? So let's say that I have a variable ch of data type char initialized to, this is the char literal single quote, lowercase a single quote, so it represents the lowercase a letter. I don't remember what is the ASCII code for that one, 94 maybe? I don't know. Anyway, so now that I have this value stored in ch, what's happening if I do system.out.println ++ch? Plus is a unary pre-increment operator, right? So we're going to review a little bit that guy here. But I increment ch, first thing, and then the result of ++ch is the new value of ch that has been incremented. So what happens if I increment the index that is stored inside of ch? What is the letter that's going to be displayed here in that terminal? Yeah, absolutely, B. Okay, so far so good. So A plus 1 equal B. Character A. Remember, not about the value, it's about values and data type. The character A plus the integer value 1 gives me the character B. Really, it gives me the index of the next character in the ASCII table. So the ASCII table at least is sane, right? It leaves the letters in order. Okay, so we can do that kind of stuff to go, up and down in the alphabet. What if I do system.out.println ch++? B again. Yeah, you got it. You get on top of it. Okay. So B again because of the property of post-incrementation, right? So quick reminder, post-incrementation means this expression here is going to give me the current value of ch, which is a number that represents the letter B. So I'm going to display the letter B, and then I increment by 1. So now the variable ch contains the letter C. Okay? So, yeah, definitely. And then I'm going for weird. I'm going to do h minus f times 4. So what is that going to be? And you don't need to know the code for H and the code for F to figure it out. But if you need them, I have them here on my notes. The code for H is 104. The code for F is 102. Okay? So, and you don't need them because you can just, you can make the difference between two letters and it's going to be a number that tells you how many letters are in between, right? So what do we get in this example? You got it. There we go. All right. So H minus F, 104 minus 102. If I go and check, the ASCII table, for example, 104 minus 102 gives me 2. 2 times 4, 8. But I can also look at the alphabet order, and say F, G, H, etc. How many letters are between H and F? 2 letters. So I'm going to say 2 times 4, and there we go. So yes, the arithmetic makes sense. Well, it makes sense to increment a character. It makes sense to decrement a character. We could do that too. It makes sense to make the difference between two characters. It's going to tell me how many characters are located between those two characters in the ASCII table. It doesn't make sense to multiply one character by another. Please note here, I didn't multiply a character by another. I multiplied the difference between character, which is just a number, by another number, right? So this is no longer representing this part of the expression. That difference doesn't represent a character. It represents the number of characters between two characters. So addition, subtraction, they make sense. Multiplication, division, I'm going to divide A by B. Okay, in algebra, that makes sense. In characters, no, not so much. So we have at least addition, subtraction that are valid arithmetic operations on the character data type, the char data type, okay? And then we finally get to the point that you were raising sooner, right? So do we have to know those codes? Well, no, because if you look at the ASCII table and the Unicode table, they have a certain logic, right? So for example, the ASCII table is going to list A, B, C, D, lowercase, one after the other. Now, it may list the uppercase version, after or before, I never remember, but they are going to be also consecutive. So once you are on an uppercase letter, you know that by adding one, you go to the next letter. By subtracting one, you go to the previous letter. Same thing for lowercase, same thing for the digits. The digits characters, character 0, character 1, character 2, up to 9, they are ordered, in that order in the ASCII table so that you can do some arithmetics on them as well. So once you know that, if you want to check, for example, if let's say that I have a variable ch of data type char, right? I want to check if that character is actually an uppercase letter. I can write it like that. If ch greater or equal to a and ch lesser or equal to z, single quotes, character literal, then I can say ch is an uppercase letter. If it's between a and z, lowercase, it's a lowercase letter. If it's between 0 and 9, it's a numeric character, okay? So quick reminder here, but I'm going to go fast because I keep reminding you about this. You guys are going to get bored of it, Yes, the curly braces are not mandatory here because I have only one statement in each of the if part. And then those extra parentheses here, and here, I don't need them either because of the priority of operators. Okay, so we talked about that already. Just putting that out as a reminder so that you don't let it slip by. Okay, these are important things. Question in the chat. By default, it's checking the ASCII table for those statements, right? Yeah. Well, okay, that's a good question. It's checking the code of the character. Okay. Now, I have not looked whether the code is by default stored as a Unicode or as an ASCII table code. I'm guessing by default, it's stored as a Unicode behind the scene because that's the largest table. That's the one that allows us to do internationalization. Okay, so it uses the simple answer. It uses a code. Okay, but then the deeper question that's behind your question is, which code is it? ASCII table code using only 8 bits or Unicode using 16 bits? Okay, so that I would have to double check. But yeah, it doesn't need anything more than just the numerical code in CH to figure out if ch is greater than 0, because when it sees a constant literal single quote 0 single quote, it treats it as an index in the ASCII table as well. Okay, so it doesn't really check into the table, it just uses all of those characters as their index in the table, and that allows to make numerical comparisons. Does that make sense? So if you wanted to check if your letter was between a random Russian character and a Chinese one, how would I enter those number character in the if statement? So you would enter them as single quote, \u, okay, meaning that you're going to give me a literal character expressed as a Unicode. And then you would look at the Unicode table and you would give me the 4 hexadecimal digit code for whatever your Russian character and your Mandarin character. Okay, so you would have, you as a programmer would have to look up the table as far as I know. Okay. All right, cool. Now, there might be some editor, by the way, that allow you to also, like, especially if you have, like, you put your Windows on international keyboard mode, okay? You can generate characters like accentuated letter from the French language, you know, or like special character, etc. So you can also, there are editors that are going to allow you to type those characters there directly. If your editor supports that, then my guess is that it's going to automatically convert the character to Unicode, you know, in your code, and then Java doesn't care as long as it gets a Unicode, okay? But the editor might make it easier, you know, to say, for example, if my letter is between alpha and iota, Greek alphabet, right? Then I want to do this or I want to do that. I don't have much experience with internationalization. I try to not put French accent in my code. I learned that lesson long ago, but so I cannot tell you more. But if you're curious, you know, like drop a post on Piazza, and I'll be glad to find you some more relevant information on Unicode, because this is definitely a topic that's here to stay for a little while. So, all right, what do we have next? So we are talking about the character data type. So there is a class in Java called character, uppercase C, you know, the whole word. And inside that class, again, we have a bunch of methods, and these are super easy. Okay, so I'm going to go relatively fast over them. It's catalog, right? You just need to know that they exist. So there is a method isDigit. It takes a char as parameter, and it's going to return true, false. Is this character between 0 and 9, right? So what we did by hand with the if-else statement, we can do with those methods. Is it a letter? Uppercase, lowercase, doesn't matter. Is it a letter or a digit? That should be an or here, not of, okay? Is it a lowercase letter? Is it an uppercase letter? I want to convert this character, like lowercase a, to a lowercase letter. So lowercase a would give me lowercase a, but if I put uppercase a here, it's going to convert it to lowercase a for me, and so on and so forth. So all you have to know is that, yes, inside the class character, there are a bunch of those utility methods. How do you use them? You put characters, the name of the class, dot, the name of the method, and you pass your character, and it's going to tell you, for example, system.out.println, character dot, is this a letter, uppercase A? True. Is this a letter, single character 0? False. Okay? So you can use those in your code without, you know, without any further ado or something like that. So there's a bunch of those methods. Again, you don't have to memorize all of them and how they work, but it's good to know what kind of stuff you can do. If you ever have one character value and you need to figure out, you know, if it's a number, if it's a letter, if it's a lower, or you need to convert it between lowercase, uppercase, etc., then this is a class that you want to go explore. Okay, period. All right, and with that, we are going to wrap up here. Okay, we are exactly at the articulation between the two parts of the module, so it's a good point to stop here. Next time, we are going to talk about something slightly different. We are going to talk about the data type string. So we use text in our program. We use string with double quotes, okay, string literals. I didn't tell you a lot about the data type string. Well, I'm going to fix it next lecture after spring break. We're going to learn almost everything there is to know about the data type string, and also all the common methods that are available. And a lot of the coding bad exercise for this module 6 are going to be about the data type string. I would say this is probably the most important part of the module. Okay, everything up to now was just, hey, all of those features are available for you to use. With the data type string, we have a few concepts that we need to introduce. Question in the chat for user inputs. Is it best practice to use is uppercase method to provide consistency through the program? So what we do is, if you read input from the user, and we're going to talk about that next lecture, right? And you want to check, for example, if the user types the words, exit or something like that. It's either you are going to say, compare, what the user typed to the string exit and ignore uppercase, lowercase differences. Or, as you suggest, we could actually take an entire string. So we would not use a character method, because the character dot two lowercase or two uppercase does one character at a time. But we have the equivalent for the string class that would allow us to take a text, an entire text, and then switch it all to uppercase. So that then when we compare, we don't have to worry about comparing with exit all lowercase, exit all uppercase, or exit with the uppercase E and then lowercase everything and test all the combination, right? We transform everything to uppercase, and then we test it against the uppercase version in our code. Does that make sense? All right. So I'm going to stop the recording because I'm, again, 1 minute over time here. So thank you for your patience. But I'm not going anywhere. So if you have questions, please feel free to hang around. I know that I mentioned at least to 1 or 2 students to come and see me at the end if they had further questions. If you're still curious about the topic, that's the time. We'll dig a little further. Okay. All right. Thank you, everyone. Take care.